When you look at AI news recently, NVIDIA shows up almost every single time. Whether it's generative AI like ChatGPT, massive data centers, or AI semiconductors, NVIDIA appears in almost every topic.
At this point, it feels like if you open AI news, NVIDIA is always there. Like opening your fridge, and somehow there's always pudding inside.
That's a pretty peaceful analogy. But in reality, their presence really is that strong. In fact, NVIDIA's annual revenue has reached around $130.5 billion, and most of that growth comes from data center business.
$130.5 billion. At that scale, it's not even a wallet anymore. It's basically sitting on a national treasury shelf.
Yeah, it's huge. So today, we're going to break down why NVIDIA is so strong in AI semiconductors, step by step, in a beginner-friendly way.
But doesn't it just come down to their GPUs are really good?
That's the key point. GPUs are important, but that alone cannot explain this level of dominance. NVIDIA's strength comes from a combination of GPU hardware, CUDA software, a full stack including DGX and NVLink, and a structure that makes customers hard to leave.
So they're not just a parts manufacturer, they're more like building an entire city for AI to run in.
That's actually a very close analogy. Let's go through it step by step. First, let's clarify what a GPU actually is.
I always thought GPUs were mainly for games and graphics.
That's correct. Originally, GPUs were developed for image processing. But image processing involves performing the same type of calculation across a huge number of pixels simultaneously.
So, images actually involve a lot of calculations?
Yes. Each pixel on the screen requires calculations for color, brightness, shadows, and so on, all at once.
So behind the screen, it's like thousands of tiny workers doing calculations simultaneously.
Exactly. If a CPU is a small number of highly skilled commanders, then a GPU is a massive factory with thousands of workers operating at once.
And AI works well with that kind of factory?
Extremely well. AI, especially deep learning, involves a huge number of matrix operations. In simple terms, it's repeating multiplication and addition an enormous number of times.
I thought AI was doing something more magical.
It looks magical, but the core is actually very repetitive.
So AI is basically hardcore math training.
Exactly. Math muscle training. For example, training large AI models involves feeding massive data sets repeatedly and adjusting weights. Each iteration requires a huge number of matrix operations.
What happens if you try that with a CPU?
It becomes too slow to be practical in many cases. That's why GPUs, which can process many operations in parallel, are essential.
So the bigger AI gets, the more important GPUs become.
Exactly. But here's an important point. GPUs are not exclusive to NVIDIA.
Then why is NVIDIA dominating?
That's where the next topic comes in.
If GPUs exist elsewhere, I still don't understand why NVIDIA is so dominant.
That's where CUDA comes in.
I've heard the name, but I don't really understand it.
CUDA is a software platform provided by NVIDIA that allows GPUs to be used for computation. According to NVIDIA's documentation, CUDA was introduced in 2006 to enable GPUs to handle general-purpose computing beyond graphics.
So it turned GPUs from graphics workers into calculation workers.
That's a great way to put it. The key point is that most AI development has been built on top of CUDA. When developers build AI systems, they often use frameworks like PyTorch or TensorFlow, which rely heavily on CUDA.
So even if developers don't realize it, they're building on NVIDIA's foundation?
Exactly. And over time, NVIDIA didn't just sell GPUs, they built the entire foundation for AI development.
So it's like a ramen shop that doesn't just provide noodles, but also the soup, bowls, chopsticks, ticket machine, and even the background music.
That escalated quickly, but it's actually not a bad analogy. Another important point is switching cost.
Isn't switching just a matter of changing hardware?
Not really. Switching away from NVIDIA often requires rewriting code, re-optimizing performance, and risking lower performance.
That's like moving houses and rebuilding all your furniture from scratch, plus rewiring electricity and plumbing.
Exactly. That's why companies often choose NVIDIA even if it's expensive, because it works reliably.
So NVIDIA's strength isn't just the GPU itself, but everything around it.
That's the key understanding.
Okay, I get that CUDA is powerful, But the hardware itself is also strong, right?
Of course, NVIDIA isn't winning with software alone. The hardware is also extremely advanced. For example, GPUs like H100, H200, and the newer Blackwell architecture are specifically designed for AI workloads.
What exactly are those used for?
Mainly for two things: training and inference.
What's the difference?
Good question. Training is the process of building an AI model. You feed it massive amounts of data and let it learn patterns. Inference is when you use the trained model to generate outputs. For example, when you ask ChatGPT something and get an answer, that's inference.
So, training is like studying, and inference is like taking the exam?
Exactly. Training is the long preparation, and inference is the actual usage.
So, AI is basically cramming for exams all the time.
More like doing non-stop training in a giant data center. And in those processes, performance isn't just about raw computation. Memory is also critical.
Memory matters too?
Very much. Large AI models handle enormous amounts of data, so GPUs need to read and write data extremely quickly. That's where high bandwidth memory, like HBM, becomes essential.
So, even if the chef is fast, if ingredients don't arrive, nothing gets cooked.
Exactly. Even a world-class chef can't cook without ingredients.
We went from ramen shops to fine dining now.
AI semiconductors are basically a kitchen at scale. Also, large AI systems don't use just one GPU. They use hundreds or even thousands of GPUs connected together.
That many?
Yes. So communication between GPUs becomes critical. NVIDIA has technologies like NVLink and NVSwitch to enable high-speed communication.
So, it's not just individual strength, it's team performance.
Exactly. NVIDIA strength lies not only in individual GPUs, but in making them work together as a massive AI system.
So, what exactly is full stack?
Full stack means providing everything from top to bottom. NVIDIA doesn't just sell GPUs. They provide servers like DGX, networking like NVLink, and software like CUDA.
So it's like a complete package?
Exactly. If a company wants to build AI infrastructure from scratch, it's actually very difficult. They have to figure out which GPUs to use, how many to connect, how to design networking, how to manage cooling, how to set up software, and whether performance will be stable.
That sounds like you tried to buy a PC and ended up becoming a data center engineer.
That's not far from reality. But NVIDIA simplifies all of that. They basically say, this setup works, this software runs properly, and this system is optimized.
So companies can just buy it and start using AI.
Exactly. And the biggest issue companies face is uncertainty. What if it doesn't work? What if performance is unstable? What if debugging is impossible?
Imagine buying expensive GPUs and ending up with a very expensive heater.
That's not even funny. That's why large companies prefer NVIDIA. They want reliability. So NVIDIA isn't just selling chips, they're selling a near-complete AI environment.
And once companies adopt that, they can't easily leave.
Exactly.
At this point, NVIDIA feels almost unbeatable.
They are extremely strong, but there are still risks. The biggest one is customers building their own chips.
You mean companies like Google and Amazon?
Exactly. They use NVIDIA GPUs, but they are also developing their own AI chips.
So they're both customers and potential competitors?
That's right. From the perspective of cloud companies, NVIDIA GPUs are powerful, but also expensive. They also consume a lot of electricity.
AI must have insane electricity bills.
Very much so. In AI data centers, power efficiency is a major concern.
So AI is like a student that eats too much electricity.
More like tens of thousands of students eating at once. That's why companies want to design their own chips optimized for their workloads. Google has TPU, Amazon has Trainium.
So, those could replace GPUs?
In some cases, yes. For specific workloads, custom chips can be more efficient.
So is NVIDIA in danger?
In the short term, NVIDIA is still very strong because of its ecosystem, performance, and system integration. But in the long term, competition structures may evolve.
So it's not about losing immediately, but the battlefield might change.
Exactly. The stronger NVIDIA becomes, the more others try to reduce dependence on it.
When the king becomes too strong, everyone starts planning how to counter him.
That's a perfect way to put it.
Now I feel like I finally see the full picture.
Good. Let's organize everything. NVIDIA's strength is not just about GPU performance. It's GPU optimized for AI, CUDA locking in developers, and full-stack systems creating dependency.
Each part makes sense individually, but together it feels like a final boss.
Exactly.
Like a combining robot.
A very strong one.
AI semiconductor squad?
The name is weak, but the structure is strong. Let's go through the key points. Point 1. GPUs are perfectly suited for AI's massive repetitive calculations.
So AI is basically extreme math training.
Exactly. Point 2. CUDA is the industry standard. Most AI development relies on CUDA, making NVIDIA the default platform.
So they control the development environment itself.
Yes. Point 3. NVIDIA provides not just chips, but full AI infrastructure. From DGX systems to software, everything is integrated.
So they're more like an AI construction company than a chip company.
That's a very accurate way to put it. Point 4. However, customer internalization is a long-term risk. Companies like Google and Amazon are developing their own chips.
So today's customers could be tomorrow's competitors.
Exactly. So when analyzing NVIDIA, it's not enough to look at GPU performance alone. You need to consider CUDA, system integration, customer relationships, and industry structure.
Today really changed how I see NVIDIA.
It's not just strong.
It's controlling the roads, electricity, and water of the AI world.
That's a great summary. That's all for today. If you now see that NVIDIA's strength goes far beyond just GPUs, then this was worth it.
Thanks for watching today's video. See you next time.